I'm going to talk about the definition of a very special number, e. It is defined as the limit as h goes to 0 of the quantity 1 plus h to the power of 1 over h. And it happens to be a very useful definition, as we'll see in a minute. But let's just figure out what this number is. So to get a handle on it, we graph it, 1 plus x to the 1 over x. In the normal way, we would go for a numerical method to find a limit. So I did a second calc value here, second calc value, and I put in this number here, and it came out with this number right here, 2.7182817. And I also did it from the left side, negative, left side of 0, real small number, and it came out with this number, 2.718282, so that's rounded off. And when you go to the home screen of your calculator and put in e to the first power and press enter, you get this number, which is accurate out to that many places, 2.7182818. So this is the number e, and it's very special. Okay, now we see one of the first reasons why it's very special. We can now talk about the derivative of e to the x, an exponential function. Well, we use the limit definition of the derivative. So it's, you put the x plus h, so it goes up here, your x plus h. So e to the x plus h minus just e to the x, all divided by h, limit as h goes down to 0. Do a bit of factoring here, just factor out this e to the x, and you just get e to the h minus 1 in there. If you check that, if you multiplied it back in, you would get the numerator. That's divided by h. Now, the constant rule for limits is that I can factor out this constant because this e to the x, for a specific x value, it's a constant. The limit is moving as h is variable going down to 0, not the x. The x at any specific x value, as far as this limit is concerned, once you decide on the x, then the e to the x is just a constant. So we can factor it out. And now we have this statement here. Okay, then, now let's just work on that limit part. The limit as h goes to 0 of e to the h minus 1 divided by h. Well, the e, by definition, as far as when h is going to 0, is back over here on the left. So I'm going to put that in for e right here. See, this is the e, and it's coming over into this part right there. And I have these limit statements, so it's legitimate to do that, because as h goes down to 0, that e will become the 1 plus h over 1 over h will become the e. And it's to the h power. So these h cancel out, and I just get down to this simple statement. The 1's cancel out, and I just get limit as h goes to 0 of h over h, which is limit as h goes to 0 of 1, which is 1. Therefore, the derivative of e to the x, which is, this is the limit definition, I'll simplify it out to e to the x times that limit of e to the h minus 1 over h, which turned out to be 1, so it turns out to be e to the x. So it's very interesting that the derivative of e to the x is itself e to the x, which means that at any given point on the curve e to the x, which if you graph it, looks like this. At any point you want, the slope there, slope of this tangent line, is the actual y value there. The slope is e to the x, and the y value is e to the x. Very interesting property and very useful. So know this for a test, that derivation.